they reran the test and then reinvestigated the test. So they investigated rerun makeup effects, investigated face contact effects versus full-size coupling versus a slim hole coupling, and they looked at lubrication effects for a dry face versus a wet face, or lubrication on the face. Again, same test equipment, same test. The only difference is now we've gone from a black and white photograph to a color photograph. Same equipment, same gauge measurement, the same strain gauges were used. Everything was consistent from the 68 test to the 74 test. Oh, this is 84 test. Here's a photograph of the strain gauge being placed in the undercut of the pin. And you can't see the hole drill through, but you'll be able to see it later. So here's the results of the rerun on a grade C. Again, somewhere around approximately 40,000 psi is what you're putting in the y-axis. The x-axis is our displacement, and you can see the known grade sizes as they're running through from 3/4, 7/8, and 1 inch, and basically verifying the results that they first got in 1968. And looking at some other effects as far as dry versus lube. Here are the D-grade rods, but now instead of 45,000 or 40 to 45,000 psi, in 84 they upped the results to approximately about 60 to 65,000 psi. And one of the things that we've all known is that as time has gone on, wells have gotten deeper, water cuts have gotten higher, our loads have gotten heavier on these rods. So obviously D-grade pin factors became an issue, or D-grade pin failures became an issue. So they re-looked at increasing the load on those pins. And in addition to this, and as we'll see as we get through towards the back of the slides, one of the things that I found in these documents on circumferential displacement is a lot of this stuff was done in combination with the bolted joint industry, and there were a lot of papers in the bolted joint industry that correspondingly resulted in some of these tests. For example, the undercut of the sucker rod pin. Prior to about 62 or so, the sucker rod pin, API sucker rod pin, was threaded all the way to the end of the face. So it was a full thread, no undercut or no stress relief. In about 58 or 59, we started playing with the stress relief for the undercut. And later API adopted that, and that's now the sucker rod pin that you have today. But in doing this, looking through these documents, I found an article where the ideal for the stress relief for the undercut and the pin actually came out of the bolted joint industry, where they referenced the U.S. Air Force was trying to reduce the number of pin failures or bolt failures that they had in their aircraft. So they went to a stress relief for an undercut bolt to reduce fatigue, bolt fatigue. And the engineers and owners back in those days applied that to the sucker rod connection, and API later adopted it, and that's how we have the undercut or stress relief. Here's our results of our 3/4 inch Type 78. Now, that's basically a de-alloy rod for API's nomenclatures. Now we're looking at full size, and we've got the slim hole, and we're looking at the pin lube versus a wet face. Or is this just completely lube? I think this is just the pin lube. This one is the face lube. So they were looking at the differences between a dry face makeup and a wet face makeup back in 1984. So basically they verified the CD results on C's and K's at 40 psi. They came up with a new PSI or pin pre-stress for the D-grade rods of 60 to 65,000 psi. They looked at torque requirements versus slim hole and full size, or the face coupling contact width in 84. And they looked at the lubrication effects from lubricated pins to dry, from lubricated faces to dry faces. And then these results were provided to the SC11 subcommittee that was looking at 11VR, and those changes were incorporated in the RP11VR and published. So, investigate the makeup prior to we had to redo the test when we come up the high strength rod, so we looked at the pre-stress requirements for high-strength rods. And again, we looked at C's and K's and D's to verify the pin stress in those rods. The same testing setup, equipment, strain gauges were used. And here's an example again of the 89 test that they did, where you can see again the strain gauges, and you can see where they drilled through the undercut and brought the lead wires out through on the wrench splitter through that shoulder fillet. Here are some of the results, showing the 1 1/8" rod all the way through to the 5/8" rod. By this time, that 1/2" rod was no longer an API rod. It was done on your C's and your K's and your D's and the high strength. This one in particular is the 30s, the C's, the 7/8", which would be a D alloy, and then the high strength rods. And again, on the y-intercept, you'll find the pin stress, and then on the x-axis, we'll find the displacement values in 30 seconds of the inch. So all that testing was basically looked at in 68, it was looked at in 74, it was, or 84, 74 and 84, 84 and 89.
68, 84.
And 79, 89, 89. But I also have some papers that I found that Norm now doesn't have it as of now, that where they did some testing in 91. So they have essentially looked at CD testing in every decade except from 2000 to 2010.